Hello and welcome. I am Shailesh Appukuttan and I will be taking you through this step-by-step walkthrough of the EBRAINS Live Paper Builder tool. In this tutorial-cum-demonstration, I will be showing how to create your own new live paper. To follow this tutorial, you need an internet browser such as Chrome or Firefox. You also require an EBRAINS account. The same can be obtained via the URL mentioned here, and we shall see the steps involved as part of this tutorial. The Live Paper Builder tool allows us to create live papers from scratch in a matter of hours without requiring any programming skills. To use the Live Paper Builder tool, you require an EBRAINS account. Let us take a look at how you can request for an EBRAINS account and also give you a quick overview of the EBRAINS Collaboratory. To request for a new account, visit ebrains.eu/register. On this page, you will find information about the EBRAINS access policy. Requesting for your account is free and all it requires is an institutional email address. Users who do not have an institutional email address can also request for an EBRAINS account, but they are additionally required to submit a short statement of motivation. To officially put in your request for the new account, click on Register Today. It will take you to this form which will request for very basic information. You can fill this up and click on Register. Once EBRAINS receives your request, they will process your application and provide you with an update. For people with institutional affiliation, this evaluation process is generally very fast. Next, let us take a look at the EBRAINS Collaboratory. To do so, visit wiki.ebrains.eu. The Collaboratory offers researchers and developers an environment to work in teams and share their work with users, teams, or all of the internet. Individual workspaces in the Collaboratory are known as collabs. Each collab provides access to storage space for saving and sharing data, Jupyter Lab for running notebooks, and several other useful features. You can search for existing collabs by clicking on Collabs here at the top. For example, we can search and find all the live paper related collabs. We see that there are several of these. We recommend you create a new collab for each live paper you wish to create and publish. To do so, you first need to be logged in. Let's do that. Now that we are logged in, click on the Create a Collab button. This page will ask you for some info. You're required to specify a title for your new collab. This title can be changed later if required. The collab name will be auto-generated based on the title, but you're free to edit it. This name will appear on the URL of the collab and cannot be changed later. Also, you can optionally provide a description for this new collab. Next, we have the option of specifying the visibility of this collab. Private collabs are only accessible to team members, while public collabs are accessible to everybody, even without an EBRAINS account. Do note that in both cases, only members of the collab with admin or editor permissions can modify the contents of the collab. We shall take a look at the concept of teams in a few moments. Choose the visibility setting that you prefer. I will go with public for this demo. Now, click on Create Collab, and in a few moments, your new collab will be created. And here it is. You can perform a variety of actions via this page. For example, you can edit this homepage by clicking on the Edit button, add new items or apps using the Create button, access the storage space by clicking on Drive on the menu bar on the left, open Jupyter Lab by clicking on Lab. We won't explore these here in detail as it is a bit beyond the scope of the current tutorial. For now, we'll quickly take a look at specifying our team. We see here that there are three categories of team members: admins, editors, and viewers. As I mentioned earlier, only admins and editors have permissions for changing the contents within collabs. Currently, there's just a single user added as an admin of this collab. Let us try to add one other person as an admin. We can search either by the person's name or their EBRAINS username. By clicking on the entry, the person gets added to the team. We now see that there are two admins for this particular collab who can make changes to its contents. As we shall see later, Every live paper project is associated with a particular collab. Permissions for editing and updating the live paper are restricted to team members of this associated collab. So if you wish to work collaboratively on a live paper project, you are required to add all these users to the associated collabs team as either admins or editors. Before we leave, let us go to the collab's drive, that is the storage space, and upload a set of Jupyter notebooks that we would use later on. Now that I've uploaded the notebooks, for each of the files, I'm going to generate a download link and copy this for later use. Let us also visit the Jupyter lab of this collab. For each of the Jupyter notebooks that we uploaded, we can obtain a shareable link from within this lab. This link will allow users who have an EBRAINS account to directly open the Jupyter notebook within the Jupyter lab. I'll copy these links for all the 4 files for later use. Let us now go back to the Live Paper Builder tool. If you aren't already logged in, you are required to log in using your EBRAINS account before you arrive at the Live Paper Builder homepage. This page provides you with 3 options: to create a new live paper from scratch, or to continue working on an existing live paper project. We shall take a look at the last 2 later on, and for now, let's start creating a new live paper. Live papers are typically associated with traditional journal publications. It is therefore necessary to collect information about the same. As this process can be somewhat cumbersome, especially when several authors and affiliations are involved, the Live Paper Builder provides 2 options for simplifying this input. The first option is to specify the DOI of the associated publication. The tool would then try to auto-extract all the information available via the DOI. For example, we see here that all the author information is retrieved, but unfortunately the DOI does not return the affiliations. The second option is to upload the PDF of the associated publication. The PDF, as you see here, is just the article downloaded from the journal's website. We make use of a machine learning tool called Grobid for auto-extracting the required information from the PDF. As we see here, we do obtain way more information than we did via the DOI. For starters, we do have all the affiliations here. But do note that there can be minor errors in the retrieved data. Also, it might not necessarily retrieve all the required information. You might notice that here we did obtain the abstract as well, which we did not via the DOI. The success of the machine learning tool in auto-extracting info from the PDF varies from journal to journal and largely depends upon the PDF formatting. In general, the DOI method provides less information but more accurately, while the PDF method provides more info but can contain more errors. Do note that in both cases, we are able to manually edit and update the missing or erroneous data. By clicking on Proceed, we move over this extracted data to the Live Paper Builder page. We see that the extracted data has been used to auto-populate this page, and now we are free to manually edit and make changes. For this particular tutorial, I would prefer to start from scratch and fill in all the fields manually. To do so, I simply select Skip on this page and arrive at the Live Paper Builder page with none of the information auto-populated. Let us now look at each field one by one. The first input is to specify if the live paper has an associated publication or if it's a standalone live paper. Standalone live papers can be used for reporting resources arising from work that would otherwise be considered insufficient for traditional publications. These could include short-term projects worked on by interns or master's students. Since most live papers are associated with traditional publications, we shall follow the same for this example. Next, we are asked to enter the title of the associated manuscript or publication. Typically, the title of the live paper and that of the associated publication is kept the same for ease of identification, but you are free to change the same. This is followed by specifying if the article has already been published or not. If the former, we also specify the year of publication. Next, we are required to specify all the associated authors and their affiliations. Do note that you are expected to enter the affiliation in detail. Let us add a few more authors. Using the buttons on the right, you can reorder the authors and also delete them individually. Next, we specify the corresponding author. Note that you can select multiple authors as corresponding authors. Next, we specify the author creating the live paper. The drop-down list gives you the option of one of the existing authors, or you have the option of specifying somebody else. If you select other, you are required to provide their name and affiliation, just as we did for the authors. Live papers are expected to be created by one of the original authors of the study. So if you have specified other as the creating author, you are required to have an authorizing author who would have reviewed and approved the live paper created by you. For now, let's simply switch it back to one of the original authors, myself. And as you see, in this case, we no longer require the authorizing author. The next several fields request information about the publication, such as the journal where it's published, the URL to the article, how it can be cited, the DOI of the article, and the abstract. For this demo, I'm going to keep most of these fields empty and add some dummy text to the abstract. Next, we have the option of specifying a license from a list of open source licenses. For this demo, I'm going with this option. For guidance on choosing a license, you can visit choosealicense.com. Now we come to the main part of the live paper, the resources. At the start of this section, you have a text field where you can provide a brief description of the resources or convey any other information. Before we take a closer look at the resource section and see all the different kinds of resources that can be added to the live paper, I would like you to take a look at this preview option here on the bottom toolbar. You can click this button at any point to visualize how the resultant live paper would look. As we see here, the live paper contains the information that we have already provided, such as the author info, the abstract, and so on, but with an empty resource section. The preview option is useful to ensure that your live paper is turning out as intended. Let us now start adding resource sections to the live paper. Do note that I have already prepared a set of sample files for the various types of resources, such as notebooks, morphologies, electrophysiological recordings, and models. For notebooks, it also includes the Drive and Jupyter Lab URLs we retrieved previously. I will share these with you on the tutorials page of the live papers documentation. The blue toolbar on the live paper builder page allows us to add different kinds of resource sections to our live paper. The generic section, as the name suggests, is the most general purpose section that can be used for providing any kind of resources. There are no integrated tools associated with this section, and it simply allows you to provide a tabulated list of resources. Many of the actions available within the different types of resource sections are common, and we shall thus discuss these within the context of the generic section. Let's start and add our first generic section. Each section allows you to specify an icon and a title to be associated with it. You can optionally also provide a description. You may click on the question mark for further information on the input format. As indicated here, the description field can accept both Markdown as well as LaTeX. I'm going to use this section for sharing the 4 Jupyter notebooks that we had uploaded previously. To do so, I click on Add Row 4 times to obtain 1 row for each Jupyter notebook. Let us add the first couple of notebooks. For each entry, we provide a label or a title for that entry, followed by a download URL from where the users can download that file, and optionally also a view URL to redirect the users to a page where they can examine and explore the file from within their browser. Let us quickly add the second entry as well. You would have noticed that the input area, especially for the URLs, is a bit cramped. To help with this, you have the option of expanding the view. Let's give that a try. As you see, you now have the full width available for each of the entry fields. This often makes it much easier to both view and input the data. Let's add the remaining 2 entries using this view. Now that we have the 4 entries, let's go back to the compact view. You can change the order of the items by moving them around using the up and down arrows on the right. Another useful feature is that of grouping items into categories. To do so, move this slider to the right, and now you see that there's an extra column called tab name. To group items together, assign them the same tab name. Let us group the first two notebooks to a category named Basic and the other two to a category named Advanced. Let us quickly take a look how this would look in the final live paper using the preview option that we saw earlier. As you see here, we have all the contents from before, and additionally now we have a resource section named Jupyter Notebooks. If you click on this, you see that we have two categories named Basic and Advanced, and each of them contains the two Jupyter notebooks that we input. For each entry, the users have three options of downloading them, viewing them online, or cloning them onto their own Collab workspace. Let us go back and look at some of the other options. As another way to alter or edit the data, you can directly access the underlying JSON object by clicking on Edit Source. This method is particularly useful for programmatic input of large listings of data, wherein you can run a Python script or other code for developing the underlying JSON data. We can also edit the JSON content from within this window. For example, let's change the names of all the Jupyter notebooks. Click Proceed to have the changes copied over to the live paper. And all the notebooks now have new labels assigned to them. You can also use the same view to add additional items to the listing. For example, let's add a fifth Jupyter notebook entry. Which is now available in the live paper. For help with the format of the JSON input, you can click on Help. This then provides you additional info about the expected JSON structure along with examples. Do note that each of the different resource sections might have slightly different requirements for the JSON input, so do double check the help section for each of them. You can also delete individual items by clicking on this cross button. Let us go ahead and delete all the entries. Live Papers provides yet another method for inputting large listings of resources in a single go using a spreadsheet-based interface. To access this, click on Input tool. This takes you to another integrated tool which has a spreadsheet-based input area at the top and a place for displaying the auto-generated JSON object at the bottom. Section type indicates the type of resource section you're currently handling. There are two modes, Basic and Advanced. Advanced gives you access to all the columns, whereas Basic only shows the common ones. You can also choose the number of rows you want displayed. What this tool allows you to do is to copy over data from a spreadsheet-based tool such as Microsoft Excel or Google Sheets and have multiple entries input simultaneously. Here, using Google Sheets, I have collected my data with labels, the download URLs and the view URLs in the same order as in the input tool. Now I can simply copy this content, paste it in the input tool, and if I scroll down, I see the corresponding JSON object has been created. I can now simply copy this using the button here and paste it over the existing contents of this box. And now we again have the 4 entries for our Jupyter notebooks in the live paper. To populate the tab names for these notebooks, we can go back to the input tool and edit the tab name column for each of these. And as you scroll down, you see that the JSON object has been auto-updated, and you can copy this and again paste it over the contents of this box. With that, we have completed entering all the information for our Jupyter notebooks and have completed this section. Let us look at some of the actions that we can perform on entire resource sections. You can collapse or expand a resource section by clicking anywhere on its top bar, or also by clicking the corresponding button on the right. This comes in handy when you're handling live papers with several resource sections and the page can get lengthy. Do note that you can change the order of resource sections. To demonstrate this, I'm going to add another resource section. Now, by clicking on the up and down arrows, we can change the order of which appears first, which appears below. You also have the option of deleting a resource section, be it empty or having content. The delete action would ask for a confirmation before the section is actually deleted. Before we move on to the other resource sections, I would like to highlight that a single live paper can contain multiple instances of the same type of resource section. For example, I can have 2 generic sections and 3 morphology sections in the very same live paper. We shall now create a morphology-based resource section. This section differs from the generic section in 2 main ways. The first is the availability of an integrated tool, the 3D Morphology Viewer. And second is the option to link to external repositories, which we shall see in more detail. Here again, we can set the resource section icon, set a title, and optionally provide a description as well. Using any of the several methods that we saw previously, let us quickly add a set of 5 morphologies to this section. Note that, as before, every item requires a label, a download URL, and an optional view URL. Here, we can leave the view URL field empty to have the integrated 3D viewer load the file using the download URL. Alternatively, you are free to specify a different view URL pointing to a different tool or a relevant web page. Actions such as expand, edit source, reordering the items, deleting them, grouping them into categories have been discussed in detail for the generic section, and we shall therefore not revisit them here again. The additional action that we have here is add from database. Let's try that out. The live paper builder allows for resources to be imported from other scientific repositories. The morphology section allows for importing entries from neuromorpho.org and the Allen Brain Atlas. For this demo, let us import a couple of entries from neuromorpho.org. Here, we have the option of searching for the entries using their ID or using the filters. In general, it is advisable to use the IDs while retrieving resources from databases, as this is much faster. We can specify multiple IDs at once, separated by commas. When we click Proceed, the tool fetches the relevant information from the external repository. By clicking on the entries, we can see the available metadata. If we wish to add this resource to the live paper, we click on Add. Every time we add a resource, this is reflected in the counter at the bottom. Similarly, we can check the second entry and also add this to the live paper. The Open Page button allows you to visit the relevant page in the external repository, thereby providing you access to further information. To confirm and enter the selected entries into our live paper, click on Add Items here at the bottom. As you would notice, 2 new entries have been added with a small text bubble next to them, indicating that they have been imported from an external repository. With that, we are done with the morphology section, but before we move on, let's preview our live paper to see how it looks. We see the second resource section named Morphologies, containing 7 entries, the first 5 being files specified by us, the remaining 2 being imported from neuromorpho.org. This is also indicated by the small icon next to these entries. You can download each of these files or have them visualized in 3D using the integrated tool. For the entries imported from neuromorpho.org, the View button would redirect users to the relevant page on that website. Note that for security reasons, the 3D Morphology Viewer only allows for loading of resources from certain domains. So if you find that your file is not being loaded and you see an error message such as this could be the cause. In such cases, do not worry. You can verify that your file indeed is compatible with the tool by clicking here on My Computer and then selecting the file and see if the morphology is displayed. If yes, then you're good to go, as during the review of the live paper prior to publication, we shall move over these resources to a compatible domain. Let us move on to the next resource section for electrophysiological recordings. This resource section has an integrated neural activity visualizer tool also called as the Neo viewer. It is based on the Python Neo project, which enables it to handle a multitude of file formats. Most of the features and actions remain similar to those seen in the previous two sections. One difference you might notice is that here we don't have a view URL. This is because for every specified item, the Neo viewer will try to load and visualize the item using the download URL. In the case that you do not wish to avail of the visualizer tool, or if your file format is not compatible with Neo, you may instead use the generic section for listing these files. Let us input a set of 5 files that I know are compatible with Neo. Now that we have filled in the information, let us see how this appears in the live paper. In the live paper preview, we see that in addition to the previous two sections, now we have a third section named Recordings and Traces, which has 5 elements corresponding to the 5 files we specified. If we click each of these, we see that there is a Neo viewer instance embedded inside. We can request for all the signals to be displayed simultaneously, or view them one at a time. Users can zoom in or pan to different regions of interest. There's also the option to download the file using the download button here. This section also provides an option to import resources from external repositories. In this case, we have access to the EBRAINS knowledge graph and the Allen Brain Atlas. For this demo, let's search for an entry from the Allen Brain Atlas using its ID. The tool retrieves the metadata of the corresponding entry, and we then have the option of adding it to the live paper. Once added, we see that it is appended to our existing list, and there's a small text bubble indicating that it has been imported from the Allen Brain Atlas. Let us now move on to the next resource section, that of models. The basic features and actions remain the same as in previous sections, so let us quickly specify a bunch of 5 models here. Here again, it is optional to fill in the view URL. The models I have chosen have previously been registered on the EBRAINS model catalog. These pages provide additional information about the models and possibly also of validation tests that have been run against them. I shall use these to populate the view URL fields. As in the previous two sections, here also you can import resources from other external repositories. Models can be imported from the EBRAINS knowledge graph, ModelDB, Open Source Brain, and BioModels. For this demo, let us retrieve a couple of models from ModelDB using their accession IDs. Once these are retrieved, we can examine the metadata and then go on to adding these to the live paper. The text bubble next to these two entries confirms that they have been imported from ModelDB. Time again to take a preview of our live paper. As expected, there is now a 4th resource section named Model Collection, which has 7 entries, the first 5 being the entries we manually entered, and the last 2 imported from ModelDB. For each of these entries, we can download the source code of the models, or view additional information about these either via the model catalog, or the relevant ModelDB page for the last 2 models. Let us now move on to the last section, the Custom section. It is named so because it is completely customizable. By clicking on the question mark, we can see some simple examples of the kind of input it accepts. It can accept Markdown input as well as HTML input. Internally, it converts Markdown input to the equivalent HTML code. Let us try out the examples provided here one by one. So we copy over the Markdown example, paste it into the code editor field, and you see that the code gets auto-indented and formatted. And now let's click on preview and see how this appears. We see that the resource section now additionally contains a custom section, which contains the Markdown table as intended. Let us go back and check the HTML example. We copy over the HTML code and paste it into the code editor. On previewing, we see that an equivalent HTML table is now displayed. Do note there is an option to expand the code editor field to see more lines of code. Let us now try a different example. I'm creating a button using HTML. and now previewing the live paper. So now we have an ordinary looking button that doesn't really do anything. Let's improve its appearance by assigning it a CSS class and also adding some JavaScript functionality. So now on clicking this button, we should be able to open the eBrains Live Papers service page. Let us check the preview. And voila! Exactly as we expected. We have a nice looking button, and when we press it, we can access the target web page. This was a very simple example of how to use HTML code to obtain some custom functionality. The custom section ensures that live papers are not limited in their complexity. Users are free to import CSS style sheets, JavaScript files, and other resources to obtain custom functionality as desired. In short, this is a very powerful section with lots of possibilities. If your data sharing requirements are not met by any of the other sections, it can certainly be achieved via the custom section. Now that we have covered all the available resource sections, I would like to switch your attention to this toolbar here at the bottom. It offers you 4 actions, namely preview, download, save, and submit. As we have seen the preview feature in action several times, there is no need to revisit it. Instead, let's directly move on to the next button, the download action. By clicking on this, you see that 2 files are downloaded. One of the files is simply an HTML file that gives you a preview of how the live paper appears at that moment. This file serves no other purpose and cannot be loaded back into the live paper builder tool. For that, we have the second file with the LPP extension, which stands for Live Paper Project. As you see here, it's a simple JSON file that contains all the information about your live paper. You would see a bit later in this tutorial how these files can be loaded back into the live paper builder tool to continue developing from where you left off. It is possible to manually edit these files before loading them back into the live paper builder tool, but I would not advise the same unless you're really confident about the changes being made. You would notice that the downloaded file names contain both the date and the timestamp. This helps ensure that files are not automatically overwritten when you download them several times over the course of a live paper development project. I would recommend you to download these files from time to time as a backup of your project. This next button here allows us to save the live paper on the eBrains knowledge graph. When you click on this, it will ask for 2 inputs, the name of the host collab and the name with which to save the live paper. This drop-down menu provides a listing of all the collabs that you have access to. Select the collab as per your choice, but do remember from our previous discussion about the EBRAINS Collaboratory and Collab that only the team members of the collab that you specify here will have access to edit and update the live paper project. I'm going to select the live paper tutorial collab that we had created previously. The save name is by default set as the live paper name, and I shall go with the same. Once both these inputs are specified, you would see that the Save to KG button is now available. Clicking this button will save the live paper project on the eBrains knowledge graph. As we shall see ahead, you would now have the option of loading the live paper project from the eBrains knowledge graph to continue development. Also note that the text message here has changed, indicating that the save action was successful. The last button left for us to see is the Submit button. Clicking on this allows us to choose between 2 actions: to request for a live paper to be published or to have it password protected. To request for a live paper to be published and thereby have it publicly accessible to everyone, you need to send us an email addressed to one of these email addresses here with the following subject: request to publish live paper. And in the body of the email, you are requested to copy and paste the contents specified here. You can simply click on this green box to have the contents copied to clipboard and then have it pasted in your email. All further communication regarding the review and publication process would be continued via emails. Do note that it is essential to have your live paper first saved on the eBrains knowledge graph before you can request for its publication. The other option that we have here is to password protect your live paper. And this can be particularly useful during the peer review phase of your associated journal publication. What this allows you to do is to specify a password for your live paper with minimum 6 characters, such as this, and click submit. And you would see this dialog box, which confirms that your live paper is now password protected. This live paper can now be accessed at the URL mentioned here, but only with the correct password. So to have it shared with the editors, reviewers, or other collaborators, you require both the URL as well as the password. Note that password protected live papers are rightly not displayed in the listing of published live papers. Let us now try to access this password protected live paper. When we try to access this URL, we see a pop-up that requests for the password. Let us enter the password that we had previously set. And there it is, we have access to our live paper. Let us also quickly check what happens when we enter the wrong password. So I enter some random input here. In this case, we see a message saying that the password might be incorrect, and we rightly do not have access to the live paper. Now coming back to this very first page of the live paper builder tool, there are a couple of options we haven't explored. We have seen how to start a new live paper project, but now let us see how we can load an existing project and continue working from where we left off. The first of these options is the load from file feature. This allows us to upload a live paper project, or more specifically, the .lpp JSON file. We have seen previously how to obtain this file by the download button. So let's give this a try. I am uploading the .lpp file that I had downloaded after we completed uploading all the resources to our sections. And as you see here, all the information has been reloaded. This includes everything from the publication associated metadata to each and every resource item that had been specified. This method of download and load from file provides a useful method to back up your live paper projects locally. The other method to continue working on a live paper project is the load from KG feature. This allows you to continue working on a previously saved live paper project. When you click on this button, you are provided a listing of all the live paper projects that you have access to. Since the live paper projects are sorted by last modified date as default, it is easy for us to locate our recent live paper. Alternatively, I could have used the search box at the top to find our live paper. I select our project and then click on Load Project here at the bottom, and we see that the live paper builder is now open with all the information that we had previously specified. These two features that we have just seen, that is load from file and load from KG, allow users to work on live paper projects over multiple sessions and even with multiple collaborators working on it together. That is the end of this tutorial in which I have demonstrated how to create a collab on the EBRAINS Collaboratory and basically everything that there is to learn about creating a new live paper. So go on to the live paper builder tool to start building your own live paper. EBRAINS live papers have been developed through the efforts of many different people with financial support from several organizations. I would also like to thank the developers of the integrated tools and services. These have been mentioned on the documentation page. For more information, check out the documentation at livepapers.brainsimulation.eu/docs. If you have any questions, you can contact us through our GitHub repository, eBrains support, or the eBrains community.